Questions 21 through 25 on the 2020 Grade 10 AMC 10B. In square ABCD, points E and H lie on AB and DA respectively, so that AE is equal to AH. Points F and G lie on BC and CD respectively, and points I and J lie on EH, so that FI is perpendicular to EH and GJ is perpendicular to EH. See the figure below. Triangle AEH, quadrilateral BFIE, quadrilateral DHJG, and pentagon FCGJI each has an area of 1. What is Fi squared? Well, each has an area of 1. This has an area of 1. This has an area of 1. This has an area of 1. That has an area of 1. So that means the total square has an area of 4. And if the side of the square is, say, S, then S squared is 4, and therefore S is 2. So the side of the square is 2, like that. Okay, now this, they have told me, is equal to that. AE is equal to AH. So I can just call it something, whatever you want to call it. Let's call it A. And therefore by Pythagoras, A squared plus A squared will be equal to HE squared. And an easier way to figure out the value of A is just use the fact that this triangle has an area of 1. So 1/2 base times height, which would be A times A, is equal to 1. So A squared is equal to 2, and therefore A is equal to root 2. So I'll put that in here, root 2, it's equal to root 2. All right, so now where do we go from here? Well, we need to figure out some more distances. I can now figure out HE up here. Since A is root 2, that's going to be 2 plus 2 is equal to HE squared. And therefore, that's 4, so HE is equal to 2. And that's HE is this distance right here, from here to here. All right, what else can I figure out? At this point, I'm going to draw a line that they didn't draw, and that's a diagonal from A all the way to C. And just label where it crosses this line, that point right there, I'll just call that N for now. Have to use some letter. And then I'm going to cut this part down like this to join G to F. Now, I can figure out the distance from A to N using the fact that that is perpendicular. So it can behave as a height for that triangle, AEH. So very similarly, 1/2 base times height, 1/2 base HE times height AN is equal to 1, because that 1 is the area of that triangle AEH, according to the question. So that means HE is 2, 1/2 AN is equal to 1, so AN is equal to 1. All right, so we're making some progress here. Now at this point, my strategy is to involve this trapezoid, CNIF, that trapezoid right there. Now, it's half of this pentagon, and the pentagon, they told me in the question, has an area of 1. So CNIF would have an area of half of that, so that's a half. Now, how do you figure out the area of a trapezoid? If you remember, area of a trapezoid, I'll just draw a simple example here. Let's say we have a trapezoid, and this is A, and this is B, and this is H. The area is A plus B over 2 times H. So in a very similar way, if you look at this guy right here, we are going to write it in the same way. But first I need to figure out some of these sides. The distance from here to here, Fi, I'm going to call x, and therefore the distance from here to there is also going to be x. So that is going to be from there to there. So this point right here, I guess I'll have to label it. I'll just call it P. this point right there. All right. So now we have to look at angles very briefly. This is an isosceles triangle. So that means this is 45 and this is 45, the degrees. Now, if you look at it, this was obviously a right angle since that's corner of a square. Now, since these lines are perpendicular right there like that, and then therefore obviously this is a right angle because that's a corner of a square, this angle therefore has got to be 180 minus 45, which is 135, right? And therefore we can figure out this angle, since the sum of all those angles would be 2 times 180 because those are two triangles. And we already have a 90, a 90, and a 135. So that can easily be figured out. It would be 360 minus 90 minus 90 minus 135. And therefore that is 45 right here. Well, we know that this is 90. And therefore this little guy in there has got to be 45 degrees, this angle right here. And by the same sort of principle, this will be 45, or even if you didn't know that, since that's 90, this has to be 45. So this is isosceles also, this little guy, because of that angle chasing that we did. So that means this is going to be the same as that in terms of the length. And in addition to that, because this is 90 degrees, this will be 90 degrees, and therefore now this is 45 and that's 45. So again, we've got another isosceles triangle, so this is the same as that. So all of that to show that CP is the same as PF in terms of its length. All right, so I think we're ready to start tackling the area of the trapezoid. We're going to need some lengths though. First, we're going to have to calculate the lengths before we substitute it into a formula. The first length I want to figure out is AC, which is the diagonal, and that's easy. That's just going to be AC squared is 2 squared plus 2 squared. So that means AC is root 8, which is 2 root 2. Okay, simple enough. And then now I can figure out CN. CN is AC minus this distance, AN. And both of those we know. A all the way to C we just figured out was 2 root 2. And AN we had previously figured out was 1. So CN is 2 root 2 minus 1. Now let's figure out at least one of these. Let's figure out the value for PF or CP, either one. CP is going to be that entire diagonal, which is root 2, minus this 1 minus this x. So minus x minus 1. And that entire diagonal is actually 2 root 2. Right, AC is 2 root 2. Okay, so I think we're ready. So here we go with CNIF right here. Using that formula, it's going to be this plus that over 2 times that height. So that basically boils down to CN plus Fi over 2 and times the height, which is PF. And that is equal to a half. Well, Cn, what do we have here? 2 root 2 minus 1. Fi is x, so plus x over 2. And then PF, what do we have? Do we have anything? Well, PF we concluded was the same as CP, and CP is right here. 2 root 2 minus x minus 1. And that all equals a half. Okay, so I think the halves will cancel, so all we'll be left with is just multiplying that out. And I'm going to rearrange this ever so slightly. I just switched those to make it a little bit easier when I expand it. Okay, let's expand it now. So it's going to be 2 root 2 minus 1 squared. And then the second term and the third term will cancel, and then it'll be minus x squared, and that is equal to 1. So that basically means that x squared will be this 2 root 2 minus 1 squared minus 1. Let's expand that. So that's going to be 8 minus 4 root 2 plus 1 minus 1 is x squared. So that is 8 minus 4 root 2, which is x squared. Now x was used to denote fi, so that is basically fi squared. And that's exactly what they wanted us to figure out. 8 minus 4 root 2. So number 21, B is the answer. What is the remainder when 2 to the power of 202 plus 202 is divided by 2 to the power of 101 plus 2 to the power of 51 plus 1? Well, let x equal 2 to the power of 50. So if I make some substitutions here, it will be the following. 2 to the power of 202 and 2 to the power of 101 and 2 to the power of 51. I will have to use that as a substitution. Okay, let's write this out. 2 to the power of 202 plus 202, and then 2 to the power of 101 plus 2 to the power of 51 plus 1. Okay, so these are my two expressions. This can be broken up into 2 to the power of 2 times 2 to the power of 200 plus 202. This is 4. 2 to the power of 200 would basically be 2 to the power of 50 to the power of 4 plus 202. So that would be 4x to the power of 4 plus 202. Okay, now let's do the same kind of substitution here. I think that can be broken into 2 to the power of 1 and then 2 to the power of 100. 2 times 2 to the power of 50 plus 1. Okay, so we have 2 times 2 to the power of 50 all squared plus 2 times 2 to the power of 50, which is just x, plus 1, and then that's going to be just x squared. Okay, so we boiled it down to this. Now, we have to, when this is divided by that, all right, so long division, when 2 to the power of 202 plus 2, that's this guy right here. So when this, I'm going to put the 202 out here since there's nothing in between, no x to the power of 3, no x to the power of 2. And it's going to be divided by 2x squared plus 2x plus 1. And I've got to figure out what goes here, and then that hopefully will give me the remainder. Okay, here we go. Okay, so how many times does 2x squared go into 4x to the power of 4? I believe 2x squared. So multiplying, I get 4x to the power of 4 plus 4x to the power of 3 plus 2x squared. Okay, let's do the subtraction. And that's going to be 0 minus 4x cubed minus 2x squared. Okay, so now how many times does this go into here? I believe negative 2x. So negative 2x, so let's do this multiplication. That's going to be minus 4x to the power of 3, and then minus 4x squared minus 2x. Okay, now let's do the subtraction. So that's 0 minus 2 plus 4, so plus 2x squared, and then this is 0, so 0 minus 2x would be plus 2x. And then I think at this point I can bring the 202 down. Alright, so how many times does this go into that? Well, it looks like 1 plus 1. So that's 2x squared plus 2x plus 1. Now do the subtraction. 0, 0, and 201. There we go. So the remainder is 201, as indicated right there. So the answer to number 22 is 201, which would be D. Square ABCD in the coordinate plane has vertices at the points A, 1, 1, B, negative 1, 1, C, negative 1, negative 1, and D, 1, negative 1. Consider the following four transformations. L, a rotation of 90 degrees counterclockwise around the origin. R, a rotation of 90 clockwise around the origin. H, a reflection across the x-axis. V, a reflection across the y-axis. Each of these transformations maps the square onto itself, but the positions of the labeled vertices will change. For example, applying R and then V would send vertex A at 1, 1 to negative 1, negative 1, and would send vertex B negative 1, 1 to itself. How many sequences of 20 transformations chosen from LRHV will send all of the labeled vertices back to their original positions? All right, so we're going to need a lot of space for this. So here we go. Now, let's say I've got a basic sort of diagram that shows the coordinate plane. So this is point A, B, C, and D, right? This is the x-axis, this is the y-axis. All right. Now, we have to have 20 transformations. So 1, 2, 3, 4, dot, dot, dot. You get the point. 20 of them. Now, each of these has four possible choices. It can be either L, R, H, or V. So I've got four choices here, four choices here, four choices here, and so on. So when you multiply them all, that's how many different combinations there are, and that's 4 to the power of 20. Now all the answer choices are in powers of 2, so I'm going to just immediately convert that to a power of 2, which is 2 to the power of 40. And interestingly, as you can probably see, all the answer choices are less than that, which makes sense because this is the absolute total. It would make sense that since we have some restrictions, our answer would be less than that. Okay, so far we're on the right track. Now, what I'm going to do is just concentrate on what happens when I make a transformation for one of these. So let's just choose A. What happens to A when I make each of these transformations? Well, L is, what is L actually? I think I forgot. It's a rotation 90 degrees counterclockwise, okay? 90 degrees counterclockwise means it would basically go from there to there. This is 90 degrees. So it would end up at B. All right, so it would go to B. Now R, 90 degrees clockwise, so it would go from here to here, where this is 90 degrees, so D. And then I think x-axis and y-axis are relatively easy. So this goes to D. X-axis, reflection in the x-axis, well, that's easy. You just go to D. And then across the y-axis, it would go to B. Okay. Now that's just for one move. We've got a whole bunch. We've got 20, right? What happens when I do a second move? So B now. B for L, for R. Let me do it horizontally. For L, for R, for H, and for V. What happens? Okay. So let's figure this out. When B is going to be rotated, it will end up from there to there, where this is 90 degrees. So it'll end up to C. And then when it's rotated the other 90 degrees in the other direction, it'll go to A, like that. And then reflected in the x-axis, B will end up at C when it's reflected there. And then when it's reflected in the y-axis, it'll end up at A. Okay. So in a very similar way, I'm not going to talk you through every single one. I'll just let you figure this out for L, R, H, V. D would go to A, C, A, C. And then again, it's the same D, so A, C, A, C. And then B, we already did C, A, C, A. So after two moves, notice that this original A ends up at A half of the time. So there are 16 possible ways it could end up, and half of them, 8 of them, it ends up at A. But that's only after 2 moves. If you keep doing this, you'll notice that in general, after an even number of moves, it will end up at its original position half of the time. Okay, so that is very important. Now, I would like to do the exact same thing, but this time for B. Because I've already done it for A, and I'd like to see what happens with B. And I'm also going to conclude, before I even start B, that with this scenario here that I did for A, C will always be in the opposite quadrant. So if A ends up back in here, C will end up back there. That will be basically helping to put the original shape back into its original position. All right, so let's do the exact same thing, but this time we'll do it for B. So I think we'll be able to do it with this much space here. Okay, so here we go. So this time for B now, we have L, R, H, and V, and we're going to start and see what happens with B. And I won't talk you through it, I'll just write it out. So B will go to C, B will go to A, B will go to C for this one, and B will go to A. Now that was just the first move. What if I have a second move? And then for the second move, again, it will be L, R, H, V, and let's write it out. C will go to D, B, D, B. A will go to B, D, B, D. C will go, well, that one I've already done. And A will go to, I've already done that, B, D, B, D. I think there was a slight discrepancy there where I think this column is V and this is H. It doesn't really matter because the gist of it will not be different. So what did I show here? Exact same thing, that after 2 moves you end up at the same position half the time. There's 16 possible positions as I've listed, and 8 of them are B's. So just like I wrote here, after 2 moves, and in general after an even number of moves, it will end up at its original position 1/2 of the time. So the same story here, 1/2 of the time you will be back into the original position. Okay, and just for the sake of completeness, I've got to write in, just like how I did here, that D will be in the opposite quadrant. Okay, so now what we do is we take our total, which was 2 to the power of 40, and we take into consideration that half and that half, that we have to multiply by a half to bring it back into its original position, and then we have to multiply it by a half again to bring B back into its original position. This brings A back into its original position, then this brings B back into its original position. And we have to have an even number of moves, and we do because we have 20 moves. That is what they told us in the beginning of the question. So this becomes 2 to the power of 40 over 2 to the power of 2, which is 2 to the power of 38. And therefore, number 23, the answer is C. How many positive integers n satisfy n plus 1000 divided by 70 is equal to bracket square root of n? Recall that bracket x is the greatest integer not exceeding x. All right, well, I noticed something really quick, that if root n is the root of a perfect square, so for example, if n is a perfect square, so something like k squared, then root n would be obviously an integer. So if you took the bracket of it it would just end up being the same as root n. The bracket doesn't change it because you're dealing with an integer. So if you do that really quickly, you can substitute that into this equation, and you get n plus 1,000, cross multiply 70 root n. Square both sides and you get n squared plus 2,000 n plus 1,000 squared is equal to 70 squared times n. And if you bring everything on one side, you get n squared plus, this is going to be 2,000 minus 70 squared, and that's the coefficient for n, and then just 1,000 squared is equal to 0. So that becomes n squared minus 2,900 when you do that math, plus 1,000 squared. And then this factors very nicely, actually. You get n and 400, 2,500, negative, negative. So immediately you get n equal to 400 and 2,500. Great. Now, what if n is not a perfect square? I had said it's a perfect square. What if it's not? So what if n is not simply k squared, but there's some additional, fractional, or not actually fractional, but some additional number. So that's a bit abstract, so let me explain what I mean. Let's say k is equal to 6, right? When n was equal to k squared, then that was simple. It's just 36, which is a perfect square, as I'm sure you know. But now I'm saying it's not a perfect square. It's something plus j. So at this point, it would be 36 plus j. Now 36 plus j cannot be a perfect square. Otherwise, we're right back to this whole scenario again. And the only way it will not be a perfect square is a special condition, and that j has got to be either greater than or equal to 0 or less than or equal to 2k. And that's very important. It's very interesting, actually. So, for example, in this case, we have k to be 6. So j would be less than or equal to 12. Because watch what happens when j is greater than, when it's outside of this boundary, let's say it's 13, and we add it to 36, it becomes 49. And 49 is a perfect square. So it goes right back to this scenario. So we can't make it a perfect square again, and that's why we have to have this very all-important boundary, or range, I should say. All right, so hopefully that makes sense. So now, since we have set n is equal to k squared plus j, we have to figure out what is root n bracket. Well, that's going to be k squared plus j root and bracket. And that is pretty much going to be the same as k, because once you take the bracket, you drop the decimal part of it, and you just get the number. So this now we put back into our original equation, and off we go. So that would make me have the following: n plus 1,000 over 70 is equal to k. So cross multiply and you get m plus 1,000 is equal to 70k. And then now n is this, so I got to substitute that in. So that's k squared plus j plus 1,000 is equal to 70k. I'm going to isolate for j, so that's going to give me minus k squared plus 70k minus 1,000. And we can factor this if you really want. It's going to be k minus 20 and k minus 50. Okay. Now, j is this, right? But we have a very nice range for j. So I can put that j into that range. So j is between 0 and 2k. So it's between 0 and 2k. But j is this. So minus k squared plus 70k minus 1000 is between 2k and 0. All right, so let's take this one step at a time. Let's look at that one first, and then I'll look at that one. Okay, so this one, I'll do it over here. I don't like that minus k squared, so I'm going to multiply through by negative 1. And when I do, I get k squared minus 70k plus 1000. When you multiply through by negative 1, the sign reverses. So this becomes the other way around. So it would be less than or equal to 0 like that. If I did that correctly. And I believe I did. So now this factors. So k, 50, 20, negative, negative. So if this was a parabola, it is a parabola that opens upwards, and we want it to be less than 0, that means it's got to be this region right here. So that means k has to be less than 50 or greater than 20. And I guess it's equal to also, because it's less than or equal to. Okay, that takes care of that part. Pretty decent. Now let's do this one. This one, multiply through by negative 1 to get minus 70k plus 1000. Switch the sign, minus 2k, and then add 2k to both sides, and we get minus 68k plus 1000 is less than or equal to, greater than or equal to 0. Okay, unfortunately, this one involves a quadratic. It doesn't factor that nicely. So you do this quadratic, and you're not allowed to use a calculator, so we have to approximate now. Unfortunately, we've got to do a quadratic and approximate what the number will be. And when you do, you get 46.5 approximately and 21.5 approximately. So this is actually another parabola, of course, that opens upwards, but this time we want it to be greater than 0, so we've got to have this segment and that segment. So that means k has to be either greater than 46.5 or k has to be less than 21.5. Okay, so we have to combine this with this to get values for k. And it looks like the only integer values for k are k equal to 20, 21, and then 47, 48, 49, and 50. And for each k, you're going to get one value of n, because n is equal to k squared plus j. So if there's 6 values for k, there'll be 6 values for n. And they don't want you to figure out what those values are. They just want you to figure out how many. But just for the case of for the sake of completion, if you want to figure out n, you can. K you already have up here. J you can get with this formula right there. Just plug in values of k into there to get j, and then you'll be able to get your values of n. Not that you need to, but if you really want to during your practice, then the values of n would be 400, 470, 22, 90, 23, 60, 2430, and 2500. And at the very beginning I had gotten those two. So 6 values, and therefore number 24, the answer is C. Let D and N denote the number of ways of writing the positive n as a product n is equal to f1 times f2 dot 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 until fk, where k is greater than or equal to 1. The f at I are integers strictly greater than 1, and the order in which the factors are listed matters. That is, two representations that differ only in the order of the factors are counted as distinct. For example, the number 6 can be written as 6, 2 times 3, and 3 times 2. So D6 is 3. What is D96? Okay, I wanted to give a little bit of a primer before I jump right into this question, and that is, how do we figure this out? Well, they gave us a nice example that D6 is 3, and they even showed us how. D6 is 3 because 6 can be represented as 6, or 2 times 3, or 3 times 2. And that is the only way I can break it up into a string of numbers where the product is equal to 6. So since there's only 3 ways of doing that, D6 is 3. All right, now I want to see, is there a relationship between different D's? So for example, if I have D12, can I write that as a relationship with other D's? Let's see. What is D12, for example? We can figure that out pretty quickly. It can be either 12 by itself, or it can be, let's see here, 4 times 3, 3 times 4, 2 times 6, 6 times 2. And I think that exhausts when k is 1, it's like this. But when k is 2, I think these are the only 4. And when k is 3, meaning you have 3 numbers, I think the only way is just all the prime factors, which is 2 times 2 times 3. So we have 1, 2, 3, 4, 5, 6. So are there any more? There should be. Ah, I see. This has iterations. 2 times 3 times 2, 3 times 2 times 2. Because they even tell me that in the question. 2 representations that differ only in the order of the factors are counted as distinct. Ah, okay, so that's why. So 1, 2, 3, 4, 5, 6, 7, 8. I got 8. So D12 is 8. Now, when you fiddle around with this, you hopefully will be able to conclude that D12 can be represented as the sum of the D's of its factors. So D6, what are the factors of 12? 6, 4, 3, 2. Right? 1 they don't want because they want F1 to be greater than 1. Okay, no problem. Now, D6 is 3. D4, I can easily figure that out. D4, I can either represent 4 as 4 or 2 times 2. So D4, there's only 2 representations, so D4 is 2. D3 is just a prime number, so there's only one way of writing it, and that's just 3. So D3 is 1. And D2 is also a prime number, so there's only one way of writing it, and that's just 2. Okay, 1, 2, 3, 4, 5, 6, 7. Ooh, 7. But the answer is 8. Well, here's the thing. You have to add one more. Why? Because that final one represents just the 12. This one right here. When it's by itself. That's why we have to add that 1. So, it is indeed 1, 2, 3, 4, 5, 6, 7, 8. So, which is what we got. So that's an important sort of conclusion to come to in this question. A bit challenging, I think. I do not think it's easy, especially when you have like 2 minutes on a math contest. All right, so what do they want us to figure out in this question? D96 right here. Okay, so I will do D96 and off we go. So D96, as we have previously concluded, will be a sum of the D's of the factors of 96, which are 48, plus 32, plus 24, plus 16, plus D12, plus D8, plus D6, plus D4, plus D3, plus D2, and as previously mentioned, we have to add on a 1 at the end because that represents the representation of 96 when we have just one number. All right, so here we go. Some of these we already know, right? D2 is 1, D3 is 1, D4 we had calculated as 2, D6 we had calculated as 3. So now we have to figure out all the other ones. Okay, so D8, well, that, in a very similar way, you just break it down instead of doing it the long way. D4 plus D2 plus plus 1. Remember, you have to put the 1 at the end. Don't forget that. So this is going to be just 2 plus 1 plus 1. And that is 4. So D8, put a 4 there. And now we have D12. And D12 is D6. D12 actually we just did. Yeah, we just did D12. So that was 8. Okay. I don't need to go through that whole thing then. It's just 8. So I did that in the primer. Great. So that's 8 right there. All right, moving right along. What's next here? D16. Okay, so D16 with our same sort of philosophy is the sum of the D's of the factors. So D8, D4 plus D2 plus that 1 at the end. So that's going to be 4 plus 2 plus 1 plus 1, and that is equal to 8. So D16 is 8. All right. So I think you get the hang of this. D24. That is going to be D12 plus D8 plus D6 plus D4 plus D3 plus D2 plus 1. And these numbers are 8, 4, 3, 2, 1, 1, and 1, and that is equal to 20. All right, so we got 2 more. Let's squeeze it in on the same page. So D32 is D16 plus D8 plus D4 plus D2, and then don't forget that 1 at the end. And this is going to be 8 plus 4 plus 2 plus 1 plus 1, and that is 16. So we are almost done. And then I just have to figure out D48, which is going to be D24 plus D16 plus D12 plus D8 plus D6 plus D4 plus D3 plus D2, and then don't forget that 1 at the end. And all of these guys added up, this is what D24 was 20, D16 is 8, and then D12 is 8, and then we have plus 4 plus 3 plus 2 plus 1 plus 1 plus 1, and that is equal to 48. Okay, that was the last piece of the puzzle, 48. All right, so now I just have to add up these guys, and when I do, I get 112, and that is the value for D96. So number 25, the answer is A.